Good morning, students. So in the previous class, we have seen how to find domain of one function. है ना? So today also we'll see some more examples. We have to find domain of 1 upon x square minus 5x minus 6, domain of 1 upon x square minus 5x minus 6 and root x square minus 5x minus 6. ठीक है? चलिए, so in all these three examples I took same polynomial, है ना? So in general for all these three questions, है ना? First I will find factors of x square minus 5x minus 6. It is common in all three. ठीक है? I took one example for all three, ना? This polynomial is same. So in all three questions, one thing is common. So first we find its factors. How to find factors of any polynomial we know? Here 1 into minus 6. We need two numbers whose product should be minus 6 and sum should be minus 5. So minus 6 plus 1 is minus 5 and minus 6 into 1 will be minus 6. So x square minus 6x plus x minus 6. So x common, then x minus 6 plus 1 common, x minus 6. So x minus 6 into x plus 1. These are the factors. These are the factors of x square minus 5x minus 6. Now, if we start first question, so f of x equal to 1 upon x square minus 5x minus 6. This can be written 1 upon x minus 6 into x plus 1. Okay? Now, for which values of x this function is defined? This would find for which values of x we can get some value for f of x. So denominator should not be 0. So this function is defined. F of x is defined if this x minus 6 into x plus 1 is not 0. If it is not 0, then only function will be defined. And if it is not 0, product of two numbers is not equal to 0. It means none of them can be 0. Means x minus 6 is not equal to 0 and x plus 1 also not equal to 0. Means x is not equal to 6 and x is not equal to minus 1. So the function is defined if it is not 0, and if it is not 0 means this cannot be 0. So x is not equal to 6, x not equal to minus 1. It means we can take all the values, but 6 and minus 1 we cannot take. For 6 and minus 1, this denominator becomes 0 and then function will not be defined. If you put here 6, then it will not be defined. Okay? So what will be domain of this function? Domain of this function f will be set of real number except this 6 and minus 1. So this set of these two elements we can subtract from set of real number. So this will be domain for this function. Okay? So if any function is like this in this form, denominator should not be 0. That value you can find. For which values of x denominator becomes 0, that you can find and eliminate from the set of real number. That will be your domain. Check. Now in this case 1 upon root x square minus 5x minus 6. So for question second, so same given function can be written 1 upon root x minus 6 into x plus 1. Okay? Now again same thing, denominator should not be 0. So this is more than 0. Then this number should not be negative. Root of minus 25 is what? It is not possible. Whose square will be minus 25? Whose square will be minus 16? Whose square minus 4? We cannot find. Okay? So this x minus 6 into x plus 1 should not be negative. And cannot be 0 also, because if it becomes 0, function will not be defined. So your function in this case f of x is defined if x minus 6 into x plus 1 is more than 0. It should be positive, means more than 0. Then only this root number can be define. ठीक है? Now product of two numbers is more than 0. It means what? If you multiply two numbers and their product is more than 0, what we can say about that two numbers? So both numbers are positive. If we multiply two positive numbers, then only we can get positive number. If we multiply two negative numbers, then also get positive number. It means both are positive or both are negative. Okay? So which values can be here? So for that simple thing, put this equal to 0. Then we get x equal to 6 and x equal to -1. So on this number line, we make one number line. We plot these numbers -1 and 6 in the order -1 and 6. Okay? Now we have three intervals. From -1 to, we can go this side, then -1 to 6 and 6 to infinite side. This side negative infinity, this side positive infinity. Okay? So we have three parts of this number line. Now from these three parts, we take one value and we will put here. Then what will happen? Simple. If we take here, suppose -2, if we take -2 and we put in both, what we are getting? -2 -6, negative, -2 plus 1, negative. So negative into negative will be positive, means more than 0. Means value of x can be less than -1. We can take from the side. Okay? Then, so here we are getting negative, positive value. If we take any value of x from this portion, we get its value positive, and that we need. Then here from -1 to 6, between these numbers, if we take a number, suppose 0, and 0 will come here. So 0 minus 6, negative value. 0 plus 1, positive value. Negative into positive will be negative, but we need positive. So here this part we cannot take. From this part we cannot take any value of x. Then here after 6, if we take suppose 7, 8, 7 minus 6, 1, positive. 7 plus 1, positive. Positive will give positive value. Means from this also we can take. It means your x should be more than less than -1, and x is more than or x is more than 6. We cannot take 6 also, because if we take 6, then it becomes 0. If we take -1, then it becomes 0, and 1 by 0 is not defined. So x should be less than -1 or x should be more than 6. In both these cases, this will be positive always. And if we take x less than -1, this will be what? -2, -2 minus 6, -8, -2 plus 1, -1, -1 plus 1. Okay? So x should be less than -1 or x should be more than 6. So f is less than -1 means we are going from this side. It means what? -infinity to -1, and from that side, so 6 to infinity. These two groups you can take. So for that we take their union. So x belongs to this group. So this is our domain of function is -infinity to -1 union 6 to infinity. This will be domain for this function 1 upon root x square minus 5x minus 6. Okay? Then same thing, the third function is root x square minus 5x minus 6. So same thing will come here also, x minus 6 into x plus 1. For this also we will see same thing. Anna, it should be more than 0. Here f of x is defined. If x minus 6 into x plus 1 is more than 0. But this time this is in the numerator. So in the numerator it can be 0. If somewhere it becomes 0, then root 0 is 0 only. So it has some value. So in case of numerator, any root number can be 0 also. No problem. So this can be more than equal to 0. So that will give you x less than equal to -1. Same process will apply here. Then x less than equal to -1 or x is more than equal to 6. Now x can be 6, x can be -1, no problem. It means your domain will be, we have seen interval then 6 to infinity. So this will be domain for this function. Only difference is here open interval and here closed interval. So if any function is like this, we can find domain in this manner. Just use one number line, find the factors and put that factor 0. That point you can plot on the graph, on the number line. Then take some, we get some parts. So from each part take one value and put here, and which gives positive or whatever we need, that we can see, and that will be your required domain. Okay? Now let's see some more examples. First you can note down this. Now we have to find domain of function root of 25 minus x square, x upon 1 plus x square, and mod of x minus 2. Okay? For fourth question, same thing. We have same root function, and inside this we have one quadratic polynomial. So your f of x is defined if this 25 minus x square is more than 0. It should be positive only, and it is in the numerator, so it can be 0 also, no problem. The 25 minus x square is more than or equal to 0, then only this function is defined. Now it can be done 5 minus x, 5 plus x, if you factorize it, 5 square, the a square minus b square can apply. Again on number line, we can take a number line. If you put this 0, we get x equal to 5, and if you put this 0, we get x equal to minus 5. So minus 5 and 5. Okay? So we have an interval, this part minus infinity to minus 5, one is minus 5 to 5 and other is 5 to infinity. Okay? So take one value from this group, say minus 6, then 5 minus minus 6 means positive value. Now 5 minus minus, minus plus, minus into minus plus 6, plus 6. Okay? Then 5 minus 6 will be negative, so positive into negative will give negative value, but we need positive, so it is wrong. Okay, it is giving negative value. If you take from this group minus 5 to 5, so any number, suppose again 0 will come here, so 5 minus 0 positive, 5 plus 0 positive, so it will give positive value. Then after this more than 5, suppose 6, 5 minus 6 negative value, 5 plus 6 positive value, so you get negative value. So if we take values of x from this group, then only we can get positive value. It means what? X should be more than equal to minus 5, or x should be less than equal to 5. So this is our value of x. X more than minus 5, x less than equal to 5. This you can write, x is less than equal to 5, x is more than equal to minus 5, means x belongs to interval minus 5 to 5. Okay, so what is domain of this function? Minus 5 to 5, close interval minus 5 to 5. 5 and minus are also included. If you take 5 and minus 5, it becomes 0, and 0 has one value. Root of 0 is exist. So its domain is minus 5 to 5, close interval. Okay? Then for fifth question, f of x equal to x upon 1 plus x square. Again you have p by q form. So your q should not be 0. 1 plus x square should not be 0. Okay? 1 plus x square, if you put 0, then what will happen? X square equal to minus 1. Now whose square is minus 1? Now we have no real number whose square is minus 1. It means x square plus 1 cannot be 0. Simple thing. For all x, x square is either more than 0 or equal to 0. For all x belongs to R. For every real number, x square is more than 0. Square of any number will be positive only, non-negative. 0 also possible, non-negative number. X square is more than equal to 0. And if we add both sides 1, then 1 plus x square will be more than equal to 1. It cannot be 0. More than 1 means, so 0 will be here only, so it cannot be 0. So denominator of this function is non-zero for every x. It cannot be 0. It means your domain of f is set of real number. For every x it is defined. Whatever you want you can put, either rational, irrational, whatever, we can get some value of y. Okay, so its domain is set of real number. Clear beta? For every x, whatever x you put, we get some value of x square. X square cannot be negative for any value. So 1 plus positive value cannot be 0. So it is defined for every x. And here if we get 0, no problem. 0 by 1 plus 0 is one value. 0 is there. Okay? So its domain is set of real number. Now in 6th question we have mod function, modulus function, mod of x minus 2. In the lower classes we have find some value of mod of minus 2, absolute value. Its value is, do you remember? Mod of minus 2, absolute value of minus 2 is 2 only. Mod of 5 is 5. Mod of minus 2 by 7 is 2 by 7 only. Okay? Root of mod of root 2 will be root 2 only. It means this is defined for every x. Whatever x you want, we can put here. Either rational, irrational, whatever, no problem. We'll get some value for this one. So again its domain is, what is domain of this function? Set of real number. Okay? And this function can be given like this. Suppose f of x equal to 1 upon mod of x minus 2. So it is defined for every x, but if x becomes 2, then it will be 0. 1 by 0 not defined. Now p by q form again. So this should not be 0, and it will be 0 only when x is 2. So we can take all the real numbers for 7th question. Your domain will be all the real numbers except 2. We cannot take 2. If we take 2, it becomes 0 and 1 by 0 is not defined. So modulus function is defined for every x. Okay? So here you can take any x, but here if you take 2, then it becomes 0, and if 1 by 0, not defined. So we have to avoid 2. So in this case, set of real number is domain. In this case, set of real number except 2 will be your domain. Okay? So these are some more examples for how to find domain. Now we will find range of these functions. Now range is what? So your domain is set of values of x for which your function is defined, and range is what? Value of y which we are getting when you put values of x. Whatever domain is given, that values of x we put in the given function, and what we are getting, that is our y, and that will be range. All the values of y will form one set, that will be range. Okay, all the values of x, domain, all the values of y, range. So if x is real number, then what will be? Range. So what will be values of y? That we have to find. Values of x are given, values of y we need. Okay, or nothing, only we have to find domain and range both also. Then values of x will be your domain and values of y will be range. Input, domain, output, range. We can say what we are putting, that is input, that is value of x, domain. What we are getting, output, values of y or f of x, that is your range. So in first question, x square plus 5, and x is a real number. If x is a real number, then what is the range of x square plus 5? What will be set of values of y? Okay? So if we see x square plus 5, for any real number, what should be values of x square? If you take any value of x from this group R, what we get? X square. We cannot find asking the one particular value. Type of x square, value of x square. One value can be negative, positive, or equal to 0. So if we take any value of x, then what will be value of x square? For all x belongs to R. For all x belongs to R, what we have? x square is always more than equal to 0. X is more than 0 or equal to 0. Okay? So here we have x square plus 5. So if we add 5 both sides, what will happen? X square plus 5 is more than equal to 5. Okay? What we have here, that we added here. Now if we see this, what is it? F of x. So f of x is more than equal to 5. F of x is what? Values of y only. So y is more than equal to 5. It means your range is more than equal to 5. Means 5 to infinity and 5 is included. So if x is a real number, range of x square plus 5 will be set of real numbers from 5 to infinity. What we did with that? X square is there. So x square is always more than equal to 0. For every x, x square will be more than equal to 0. So we add just whatever, we subtract whatever number is there. Okay, so we get our, now from this condition, we are getting this function x square plus 5. And that is giving more than equal to 5. So range is 5 to infinity. Okay? Question second. 5 minus 2x. Range of 5 minus 2x. If x is real number and x is more than 0. Okay, sir. Tell you what we have. X is more than 0. Now from this condition, can we get 5 minus 2x? Can we convert x more than 0? Can we bring here 5 minus 2x? So whatever things we are having here, same we'll try to bring here. There is 2x. So we want to bring 2x here. So if x is more than 0, what we can say about 2x? Simple. One number is more than 0. It's double. Definitely will be more than 0 only. So 2x is more than 0. But here we have minus 2x. If one number is more than 0, means positive. So what about its negative value? Means if you take minus 2x. So when you multiply by a negative number in an inequality, sign of inequality will change. 2 is more than 1. And if you multiply by minus to both sides, minus 2, we are getting, after multiplying minus 1, we get minus 2 and here minus 1. Now what is the relation here between these two numbers? Which is greater? Minus 2 or minus 1? Minus 1. So symbol like this. So here 2 is more than 1, but minus 2 is less than minus 1. So in an inequality, when you multiply a negative number, sign of inequality will change. So 2x is more than 0, so minus 2x will be less than 0. Okay, then we need 5 here. So just add both sides 5. So 5 minus 2x is less than 5. And what is it? This is our f of x. So we can say f of x is less than 5. It means range of this function is less than 5. So negative side, and 5 is not included. So minus infinity to 5 is our range of this function. Okay, na? So some x, about x, if you know something, okay, then using that we can bring our given function. Check. Now in third question, 2 minus mod of x minus 3. So we have seen the previous examples, mod of x minus 3, x minus 2. So their domain is set of real numbers. So domain for this function is set of real numbers. So what will be its range? So for every x, for all x belongs to R, mod of x minus 3 will be more than 0 or equal to 0. Now, absolute value is always positive. Mod of minus 2 is 2 only. Mod of minus 5 is 5 only. Mod of minus 7 is 7 only. Okay. Mod of 5 only 5. So x minus 3, mod of x minus 3, absolute value of x minus 3 will be more than 0 only. But when x is 3, it becomes 0 also. So mod of x minus 3 is always more than equal to 0 for every x. Here we have negative again, so multiplying both sides by minus, so it will get less than equal to 0. Mod of x minus 3 is more than equal to 0, so minus of mod x minus 3 will be less than equal to 0. Then we have 2 here, so adding 2 both sides, and it is our f of x. The f of x is less than equal to 2. It means range of this function is less than 2, and 2 is included, so close bracket. So this is our range of function 2 minus mod of x minus 3. Okay? If we have plus n here, then it remains as it is. Now suppose function is 2 plus mod of x minus 3. Its range we need. So mod of x minus 3 is more than equal to 0. If we add both sides 2, so our function is more than equal to 2. So its range will be 2 to infinity, more than 2. If plus is there, range will be 2 to infinity. Minus there, this side only. So in this manner, we can find range for some other. For range, for each and every question, method is not same, but different question process will be different. So for this type of questions, range you can find like this. Okay. Now we'll see some more questions, how to find range for different functions. First you can see this. Now we'll find range of these functions. So f of x is root x minus 5. Now its domain, its domain will be set of all x from 5 to infinity. We have seen how to find its domain, and x minus 5 should be more than equal to 0. This can be more than equal to 0. So x will be more than equal to 5. So domain of this function will be 5 to infinity. This we have seen. Now for range, since for what we have, x is more than equal to 5. Okay, so what about x minus 5? X minus 5 will be more than equal to 0. Now its domain is 5 to infinity, means x is more than equal to 5. So for all x more than equal to 5, x minus 5 will be more than equal to 0. Now if any number is positive, what about its root? If any number is positive, its root will be positive only. Root of 4 is 2, positive. 8 is positive, root of 8 is 2, root 2 will be 1 positive value. 9 is positive, its root will be 3. Then 1 is positive, its root 1 only. Point, any number you take, 0.5, 0.2, 0.3, all are positive and the roots will be positive only. So root x minus 5 will be more than equal to 0, and which is our function f of x. So f of x is more than equal to 0. So range will be 0 to infinity, where 0 is included. Okay? So range of this function is 0 to infinity. If this function, if you write 1 upon x minus root of x minus 5, the function given like this. So in this case, range domain will be set of all real numbers 5 to infinity, but 5 is not included. Open interval 5 to infinity. Okay, its domain will be 5 to infinity. Then same thing we can apply here. If x is more than 5, x will be more than 5, then x minus 5 is more than 0. If a number is more than 0, its root more than 0. If a number is more than 0, its reciprocal 1 upon root x minus 5 will be more than 0 only. Okay? 5 by 2 is more than 0. So what about 2 by 5? More than 0 only. So if a number is positive, its reciprocal will be positive. And what is this? A function. So in this case, what is range? 0 to infinity. 0 is not included, and here 0 is included. Okay? Then x square minus 4 upon x minus 2. Its domain will be, so clearly we can say x cannot be 2. If x becomes 2, denominator becomes 0. So from real number you have to eliminate 2. So our domain is set of all real number except 2. Okay, this also we have seen. Now for range, what do you f of x? X square minus 4 upon x minus 2. This can be done x minus 2, x plus 2. Now x is not 2. Domain is set of real number except 2. Means x cannot be 2. If x is not equal to 2, means x minus 2 is not 0. If x is not 2, x minus 2 cannot be 0. So x minus 2, x minus 2 can be cancelled out because those are non-zero numbers. So what do you have? X plus 2. So our function can be write x plus 2. In case of domain, we cannot cancel because we don't know x is what. Now we got domain is set of real number except 2, means x cannot be 2. So now we can cancel out. Okay? Now since in our domain 2 is not present, so if you write 2 here, f of x will be 2 plus 2 4. Okay? So it means f of x cannot be 4 because we cannot put x equal to 2. If x is not 2, f of x cannot be 4. We have all the values except 2. So if we, when we put 2, then we are getting 4. It means we cannot get 4 because we cannot put 2. So since x is not equal to 2, x plus 2 cannot be 4. Adding 2 both sides. So x plus 2 cannot be 4 means what? F of x cannot be 4. It means your range is set of all real numbers except 4. We can find value of x, f of x can be any number, but 4 cannot be there because 4 only we can get when we put x equal to 2. So your range of this function will be set of real number except 4. Okay? Then in third case, root of 25 minus x square. Just only you seen its domain is closed interval minus 5 to 5. How did you find? You can see. So its domain is minus 5 to 5. Now its range. So for this case, we assume let y equal to f of x. Means y equal to root 25 minus x square. Now we write x in terms of y. Okay. One process like this you can find range for this type of function when we have root function. Okay, then we can, or PYQ form, then also we can use y equal to f of x. Then we find x in terms of y. So we get an idea, y square equal to 25 minus x square. To eliminate this root, taking square both side, then x square will be 25 minus y square. Transpose x square and y square. So x will be root of 25 minus y square. Okay? Or if you write a plus minus, no problem. Now x can be real only when it is defined. And x can take real values only when this 25 minus y square is more than 0. It is the numerator, so it can be 0 also. Okay? So for x to be real, it should be more than or equal to 0. For x to be real, 25 minus y square should be more than or equal to 0. Then same thing, 5 minus y, 5 plus y is more than or equal to 0. Now in this, for domain, we got like this only, 25 minus x square is more than or equal to 0. So now x replaces only y. So we can say y will be in this interval minus 5 to 5. And the same thing is there, only what is the difference? X square becomes y square. So whatever domain we are getting here, same thing we get here. So y is from minus 5 to 5. Okay? So value of y is in this interval. Means it is range, can be. But one more thing here, it is given y equal to root 25 minus x square. It is given more than or equal to 0. Its value can be more than or equal to 0 for all x belongs to minus 5 to 5. In this, for this values, its value can be either 0 or more than 0. It cannot be negative. So y is more than 0 and y is from minus 5 to 5. Minus 5 to 5. Okay? And y is more than 0. More than 0. One option minus 5 to 5 and one more than 0. Like this, right? This part. So in both the parts, common value from 0 to 5. So range will be 0 to 5. So range of this function is 0 to 5. If x is minus 5, y will be 0. If x is 5, y will be 0 in both the cases. But when x is between this, if x is 0, it will be 25 means 5. So value of y can be from 0 to 5. So range of this function is 0 to 5. So range of this type of function we can find like this. For range of this type of function, just cancel out common factors, and if P-by-Q form is there, and if any common factor is there, cancel out, and then you can find range. Okay, for this function like this. Okay, beta.